Can a system be unpredictable but without any random factors? The answer is yes. The chaos system.
Today, let me show you what is chaos.
Chaos is a system that its future is highly affected by its present behavior. How highly affected? Well, if there is no difference in the initial condition, then we will always get the same result. However, if there is a slightly difference in the initial condition, it will strongly affect its future. That's it. A similar starting will not end up with a similar result. This is how highly affected the chaos system is to its initial condition. But if we track these two different situations for a longer time, we will find its tendency being similar in a long-term way. And no matter how it changes, its behavior will always be limited in a certain range. Why will a chaos system be like this? To further explain it, let me take the Lorentz water wheel as an example. A Lorentz water wheel is a chaos system built with a water wheel with cups at its edge. Each cup has a hole on the bottom and can freely rotate when the water jet is flowing from the top of the wheel. When look at its motion, we will see that the water wheel will sometimes turn left and sometimes turn right. The change of its angular velocity has no periodicity, nor does it have regularity. To analyze the Lorentz water wheel's motion, we can plot a three-dimensional graph in which each axis represents a degree of freedom. There are the angular velocity of the wheel and the y and z position of its center of mass. The position of its center of mass will be affected by the distribution of water in each cup. It's not hard to understand why it looks like this. We can see that these two vortices can be separated into two parts at angular velocity equal to 0. The top vortex, in whose omega is positive, means the situation that the water wheel is spinning counterclockwise, and the vortex at the bottom represents when the wheel is spinning clockwise. Since the water wheel is spinning, its main center will keep on doing circles, so the two conditions will show a spiral shape. From this graph, we can know that the water wheel keeps on changing its direction while its center of mass is drawing circles. Since the water wheel keeps on changing its direction, a small difference in the initial condition will lead to a point that the water wheel switches its direction but the other doesn't. The angular velocity will then accelerate in two opposite directions, and this is when this system becomes unpredictable. No matter how small the difference in the initial condition is, they will always be separated into two completely different situations at a point of time. That's the reason why a chaos system is so sensitive to its initial condition, and is also what makes it unpredictable. Why will its behavior be limited in a certain range? When we look at its angular velocity, we found that the water wheel will slow down and change its direction when spinning too fast. It's because that when the water wheel spins too fast, the water will go to the other side that generates a torque against its rotation. The gravity will quickly slow it down, and that's the reason why it will switch its direction. For the position of the center of mass, it of course was limited by the size of the water wheel, so the behavior of this water wheel will be limited in a certain range. So now we have a basic understanding of a chaos system. This system needs to be limited in a certain range and has at least 3 degrees of freedom. If it only has 2 degrees of freedom, then it can only have one single phase. But if it has 3 degrees of freedom, it can have 2 different phases connecting to each other, so its behavior can keep on switching between these two phases and create a chaotic behavior. It's like when we are making a bread, there's no way to mix up the ingredients if we can only move two-dimensionally. If we have some flour, sugar, water, and one single red bean, it's very easy to tell where that red bean is no matter how long we mix them. But if we have 3 degrees of freedom, we can mix the ingredients together with 3 dimensions of motion. We can knead the dough from right to left and from left to right. Just after a short time, it will be totally mixed up and we can tell where that red bean is. A chaos system is just like this. In a chaos system, it keeps on extend, compress, and overlap in a limited range, so it can create a complicated behavior with just some simple motion. There are actually a lot of chaos systems in our daily life. Like the weather is actually a chaos system. No wonder it's so hard to predict if it will rain tomorrow or not to mention the weather in the next week.
By studying the chaos theory, we know that a similar study may not end up with a similar result. It opened a brand new door in front of us, and maybe one day, we can uncover all the secrets under the mess of chaos.